Hi guys, in this video I'm going to talk about GraphRAG. Recently we have heard a lot about this term and we don't know whether we can use it instead of our vector database. What are the limitations, what are the pros and cons, when we can get most out of them, when this all originated, and knowing where it is the most suitable time in order to use this kind of graph-based languages for our retrieval. So this is going to be an interesting video. Without further ado, let's jump right into it. Welcome everyone to your channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedram. I have a PhD in computer science, and this channel we talk about AI and machine learning and how we can use it in order to improve our efficiency. In this video, we're going to talk about GraphRAG. In order to understand where this all come from, I want to go back into year 2000s where they were doing some researchers inside the internet. So before actually Google come up, there wasn't lots of data inside the internet, so numerous different searching engines were used in order to provide the response. So how they work was based on semantic similarity and basically keyword match, so a combination of them. So these kind of approaches were actually helpful and they work until they didn't. As the number of web pages grow more and more, then the number of pages with the similar keywords or semantic similarity grow a lot, and then you have to go deep into so many pages in order to find the relevant information that you want. And that's where actually Google come in, and they actually provide this idea that they wanted to generate the next generation of search, which in that case was PageRank. So the idea came on year 2000, and that was basically the beginning of Google as the startup back then. And they actually provided this patent that try to find a way that can provide basically the most relevant information for the user specific to their query that they have. So this was something that was rolling around. And basically we see that lots of the other competitors like Yahoo, Ask, and AOL actually get out of the picture, and it rules from 2000 to 2012. Until 2012 actually Google come again and introduce knowledge graph. So they said that we want to store things, not strings. So what does that mean? That means that they created the idea of graph, which basically include the nodes, which are the entities, and the relationship, which is the edge. And that whole thing created the context. Remember, these are before the area of the large language models. So the GraphRAG has this history long before the large language model. So we go from the information retrieval to knowledge retrieval. So if you look at the response from, for example, Google, you saw that on some of the information, if you ask, for example, for a restaurant, they pop up a window beside for you that have some structured format that you can see, oh, for example, what is the address of this place, who is the owner, what's the phone number, and so on. So these structural information related to the query that you originally provided is the core concept of knowledge graph. So this knowledge graph actually was ruling the Google from 2012 until 2024. So a little bit into the LLM areas, and that's where there was a lot of basically judgment against Google that is not changing, it's not repeating in order to include the idea of LLMs. And that's where in the Google I/O 2024, the inside the keynotes, they actually introduce this GraphRAG based solution. So the GraphRAG is a very new idea that try to encompass the information retrieval capability of a graph and cope it with the semantic knowledge and information providence for the complex basic queries that the LLM have. So a combination of both of them, this is something that currently is available. Now let's talk about GraphRAG. In order to talk about GraphRAG, first we need to know what is RAG. So we talked a lot in this channel about RAG, retrieval augmented generation, which is some additional information that come on top of the LLM in order to provide most relevant information to the LLM in order to provide the response and kind of help with the whole hallucination problems. The GraphRAG is basically the retrieval component. Instead of using a vector database, it uses a knowledge graph to traverse the relationship and provide those information. So what's the power we can get from the GraphRAG is that we combine the speed of vector and the context that the graph can actually provide. And as you can see inside this picture, we ask some questions and the question comes inside the application. We get some embedding generator, the question, and then the value come back, and then we have our knowledge graph also sitting there, which basically provide the more relevant context and more context related to that specific topic. And then finally we can also the application can also talk to the LLM itself to either provide a summary or find the most relevant one, and finally we will try to provide the final answer on the step 5 to the user. So this is the whole agentic solution that you can use inside a GraphRAG, a combination of vector database and the graph database. So now let's see one of the real world example. Let's say you have a Wi-Fi router. The scenario is that the user asks, my yellow light is flashing. So what you're gonna do is that you're gonna do a vector search. You're not gonna confine to the knowledge that LLM had. So find article mentioning yellow light, and is it enough? Is this yellow light, is this related to the basically the modem, or is the yellow light for example traffic light? So you can see the idea of why this pure semantic similarity search can be not helpful when we have a heterogeneous data set, a data set of completely different basically categories or completely different area. That just semantic similarity wouldn't be enough. We need to know their relationship as well. And the whole idea of what we talked about, that graduate resulted the Google search to actually go into the graph come from. So the graph search travels to find this specific under router model. So it first try to find the router and then try to see that, okay, what are the information related to that, and then you can find the high rated engineering and then try to relate the hardware to the same family. And that's why you can basically distinguish between the specific information that you're looking for given the relation of the basically subject that you are looking for. This is also important if your question is actually more complex and intertwined. If the question actually requires the knowledge from different aspects of your page, even though if your for example PDF or the context that you have is not basically heterogeneous, still a complex one. It requires the knowledge from different portions that can result in not providing the correct response and then failing the vector data set if you don't use your GraphRAG. So we saw the benefits. There are different papers and blog posts that talk about the accuracy and multi-hop reasoning. For example, in here, they talk about the knowledge graph actually improved the accuracy of LLM response on average 3 times and about 54% faster. So this is like a groundbreaking result. And then we also have a blog post by Microsoft that they talk about unlocking LLM discovery on narrative private data, which basically they said that GraphRAG enables them to answer important class of question that they cannot attempt with the basic RAG alone solution. So This actually shows that the problem of multi-hop questions is that the multi-step questions requires, as we mentioned, answering for the specific topics that come on different places, and how you can connect them is only available if you, in the first place, have access to structured data. Now that we know all of these benefits, then a natural question in here would be, why not everybody actually use a graph database rather than vector database that is a lot more used in the real world? So the answer for that is come from the limitation, which basically how you can create this knowledge graph. That's the most extensive portion and a more challenging portion. And as soon as you have a graph base, actually providing the response from the graph is way faster and also more accurate. So the bottleneck in here is how you can create this GraphRAG. When you want to represent an apple and orange, both of them are basically fruits, right? But if you look at the representation model that basically a vector database tried to do, it's more implicit and compared to the one for graph, which is symbolic. For the fruit in here, we can actually see very clearly that the apple and orange are actually shown like this. However, basically for the representation, they are just some numbers, so it is not very easy to actually distinguish between them. And then after that, it is about how you compute their similarity, how you actually find whether this one is related or not. So for that, you need to find some basically Euclidean or a more popular one, a cosine similarity for the vector distance. In here is more structure, for example, node similarity, the overlap, the Jacob metric, and then it can be also taxonomy based, for example, the path or the other approaches that requires you to travel through the graph in order to find a response for yourself. And finally, in terms of search, they are completely different. For example, we have graph exploration methods that you find a specific node and then you try to, for example, do depth first search, or you try to basically do random walk to your neighbors in order to find the more relevant content. However, inside the vector and more sub-symbolic approaches, we have a multi-dimensional space. We want to do some search for a specific component, and we expect that closer object are actually closer object in terms of meaning are closer in terms of proximity to each other in that space. So that's why some of the approach like IVF or HNSW, which basically try to approximate this result or approximate nearest neighbor ANN solution, try to more effectively find the space that the specific component reside in. Vector database are best for semantic similarity, broad fuzzy search, and general vibes. So the weakness is that is precision, is a structural fag, and explaining why. So you cannot explain why you generated the response. However, on knowledge graph, it is very good for a structural hierarchy. If you want to find the relationship, if you want to provide complex reasoning, because that's how your components are actually related, connected to each other. But the weakness is that you require to build the structure first. You need to have the knowledge graph first in order to be able to use that. Also, there is new papers that talk about the knowledge graph gap because of this failure inside creating a complete knowledge graph. That's why for some simple basic questions, the knowledge graph actually doesn't provide as much good as precision compared to the vector data. So the verdict is that try to use both inside a hybrid approach. If it is a very simple one, you're basically better off with the vector, and for more complex one, you can consider the searching on knowledge graph. And in terms of the transparency, this is also very important, because by knowledge graph you have the information on knowing why this happens, because it is more transparent and explicit. So you can take a look at each node and see that how they are connected. So if somebody asks a question, you can basically trace back to the graph and see the relation there in order to know that, okay, how this we come up to this resolution. However, for the vector data space, it is more implicit and empiric, so it is not very clear that how we basically provide the response. So it is for a graph base, it is the explaining the answer and governance is a lot more easier. As we talked about, this is the hardest portion of the knowledge graph, the bottleneck. So there are technically three types of the data. We have a structured data. This is something that you stored in a Postgres database or in your enterprise data sets, that each of the fields have fewer number of text. However, we have on the other side complete unstructured, which is, for example, a very huge document, a PDF. And then something in the middle is a combination of them, which is more something that we see from the basically enterprise, which is basically some fields that some of the fields can have a longer text inside them. Basically, the most easier one would be the structured data. So it has a good methodology, good tools, and then also more common in enterprise. And unstructured is actually intrinsically hard, because you need to know how you want to distinguish them. And last but not least, we want to talk about the implementation strategies and how we can basically fill the gap. There are two types of knowledge graph in general. We have a lexical graph that basically represent, for examples of the words, paragraphs, chunks, documents. This is more common and more easier to actually create them. And then we have domain graph, which basically try to look at the exact tokens or the words and then find digital word and domain you mentioned and how they are actually related to each other. For the domain graph, we define specific entities, more like a name entity recognition, and then the benefit of this approach is that if you have your core business logic, then you can define what are the entities or relations that you are looking for. However, lexical is more automated, no schema is required, and more generalized. However, for domain specific responses, if you actually require GraphRAG, I believe the domain graph would be the way to go. And there you have it, guys. We went over the GraphRAG. We talked about how this all came from, where it is more useful, when we can consider using them, what is the bottleneck for them, and when is the best time to use compared to a vector database. If you enjoyed the video, make sure to like it. More importantly, subscribe to the channel so you see more videos. If you want to see more videos about how to use which LLM, you can watch this video that I talk about 8 different type of LLM and help you on how to choose the correct one. And you can watch this video that I talk about basically RAG architectures. If you are unfamiliar with RAG, you can watch this one. Thanks for watching and see you until the next one.